Good evening, everybody. It's it's a pleasure to host the Bhoo-Mandal Talk series, the next edition of that. So I'm Jaya Srivalsan Nair. I'm a faculty member at IIIT Bangalore and also the chair of IEEE-GRSS Bangalore section. So before we move on to the exciting talk we have today, I would like to give a few introduction pitches, and after that we'll move on to the introduction of the speaker and the talk, and then we'll hear Ishaan Kochhar from Blue Sky Analytics telling us more about decision making using satellite powered climate and environmental intelligence. So as an introduction, unfortunately, I'm unable to share my screen. So I will put some of the important links in the chat as I talk. So we are IEEE-GRSS, that is a Geoscience and Remote Sensing Society. And it's a society under the IEEE community. Now, the Bangalore chapter in particular has been around since 2012, and this started out in ISI Bangalore, that's Indian Statistical Institute Bangalore campus, and then it grew, and we proudly have around 50 to 60 members, which is a good count given all the chapters in India. And so if you look at the video that I have put in the chat, that is a 1-minute video snippet of what IEEE-GRSS altogether is. So it's a global community and we're just one part of it. It is a very vibrant community to promote all kinds of work in geoscience and remote sensing, starting from satellites to applications on the ground, oceanography, etc. Everything covered, right? If you would like to become members of IEEE-GRSS, there is more information on this at the homepage, so which I have put in the chat again. The IEEE-GRSS Bangalore chapter, as I mentioned, started in 2012, and the current slate that is headed by me took over in 2021 during the pandemic. So we have been quite active online, mostly active online. Some of the activities that we do include talk series, hackathons, mapathons, student paper presentations. So we try to engage a lot more with younger professionals to get them more excited about this area and contribute towards it. And given today's technology and the sharing of data, policies, and all of that, this is a very exciting place to be in. So I'll briefly now tell you about the Bangalore section's flagship talk series, which is a Bhoo-Mandal talk series. Now, this started when the pandemic started. So we started this sometime in July 2020. And we have had a series of talks. So it was meant to be monthly talks, but now we have it like quarterly talks. So the idea here is to sort of open up discussions on various aspects of geoscience, not just constrained to say electronics, hardware, software. It can transcend into policy making, society, SDGs, and so on and so forth. So this is a forum for us to discuss some of these ideas. And so what we generally do is we record these talks and we give it, these are meant to be public talks. So we put it out in our YouTube channel. So you can see the talk series in the playlist here that is typed here. Yeah. So with this as a brief introduction, now I'll pass it on to Guru Datta, who is the secretary of the chapter and who is the active member from industry in the chapter. And the idea for us is to built a lot of the industry, academia, government connections through these forums. So I will pass it on to Gurudatta, who is with Map My India, and he will introduce the speaker and the talk. Thank you. Enjoy the talk.
Thank you, Jaya Madam, for the brief introduction about IEEE and Geoscience and Remote Sensing Society. Without much ado, I'll give a very quick introduction about today's speaker, Mr. Ishaan Kochhar. He is a research lead at Blue Sky Analytics. It's a climate tech startup which uses satellite data and artificial intelligence to build environmental monitoring and climate risk assessment products. Ishaan is a postgraduate in geoinformation science and Earth observation from Indian Institute of Remote Sensing, ISRO, and the University of Twente, the Netherlands. His research is specialized in natural hazards and disaster risk management. Ishaan began his career at the Defense Research Development Organization, DRDO, as a junior research fellow. Thereafter, he pursued as a remote sensing and geoinformation analyst at the International Center for Integrated Mountain Development in Nepal. He has worked in themes of geospatial analysis and modeling. And since the past years, that is since 2020, he is working with Blue Sky Analytics. In his professional life, he is interested in developing and applying data science methodologies and workflows to Earth observation datasets. His professional and academic background is characterized by a cross-disciplinary blend of data science and remote sensing competencies. So today, Ishaan is giving us a talk about empowering decision-making with satellite-powered climate and environmental intelligence. So over to you, Ishaan. Before you get started, a little bit of housekeeping to all of you. If you have any doubts or queries, we would have a separate Q&A session towards the end. However, if you have anything, you can either you can put a query as Ishaan is speaking. You have a doubt, you can put it in the chat window, and we will take up all these questions towards the end of the talk. Ishaan, over to you. The stage is yours.
Thank you so much for having me for the talk, and I mean, it's been a great pleasure, and I've been watching these videos. So whenever I get time, and it helps us a lot as well. So before I start, so I'll just quickly tell you that I'm currently a research lead at Blue Sky Analytics. So the fun part, being a research lead at Blue Sky Analytics is, so I know I get to meet people, I talk to them, and talk to them about science, and specifically remote sensing and climate science. And most of the users, when I talk to them, or the clients, we say they are not from the science background. Like, as I think the audience, they understand, like they are interested in satellite data in general and remote sensing and climate science. But whenever I go there, talk to them, so they are not from the science background. So either they are from banking sector, financial sector, insurance sector. So a lot of them, they don't understand what we do. So we put a lot of effort. I mean, the science is there, but we make sure that they understand our data, and not just the data, how they can use it. And there's a lot of effort goes into just to summarize, like how we develop these data sets or how they can use it. There's not like one data set can solve all the purpose. So like we put a lot of effort, and that's the fun part. And over the last I mean, we as a company, we started in 2019, and now it's 2020. It's approximately, I think, 4 years now. So so over the 4 years, the kind of work we have done, or the research we have done, so I think it's incredible. I mean, from academic point of view as well. So I'll just quickly walk you through about Blue Sky Analytics. Then I'll show the how we do the processing, or how we generate the insights, and what's climate science. I mean, like if you talk to people or the non-science users, they don't understand like what climate is, what climate science is, what weather is. So it's everyday struggle for us. So we try to simplify it. So when the one thing which I realized is, I mean, before I move on to my next slide, I'll tell you a fun part that, so when I introduce about climate sciences, so weather and climate, it's like a person's like personality. So weather is something, it's the mood on any given day, and climate in general, it's a like personality. So what, as a blue sky analytics, we monitor the mood, like what's happening today. So that's what it's help us to make them understand the kind of data set we develop. So I think it's been introduced previously also. So Blue Sky Analytics, uh, we call it, it's a climate tech company. So we essentially use satellite data, not just limited to satellite data, but now there's a whole lot of ground sensors as well. We integrate not just, I mean, ground sensors, then there are reports as well. And we aggregate all those to make near real time information available to the users so that they can uh, make like decisions and into their applications or day-to-day activities. I think I previously mentioned, like, as Blue Sky started in 2019 with just three people on a dining table, like every other startup. And now, over the last 3 years, even when the pandemic hit, uh, so we actually grew to 30 people. Like, there were a lot of, uh, uh, I mean, these companies were laying off the employees, but we actually grew from 3 to 30, like just during the COVID as well. And not just that, and as the situation relaxed, so we expanded to other continents also to know understand what's happening around the globe, to get the right kind of uh, advisors, not just from India but also globally, to being a Indian startup, we want to compete the global companies as well. So we want to uh, be there. So that's how I mean, we thought of, and we are working. And over the years, more than we have 15 strategic partnerships. I mean, this is the previous, I mean, this is, my slide is not updated now. I think we are close to 20 partnerships. And these partners include from governments, some of them are from non-profits who are actually working on ground, and we get on ground information from them. It's not just that we are capturing the satellite information and giving it to the users. We try to make sure that that information, whatever we are generating, is credible, so that uh, and what are the limitations, even if we are generating some data sets. So we need to make sure that the end user need to know everything, and we want to be transparent so that they make decisions accordingly. So it's not just we are just generating the data, and I mean, it's up to you how you want to use it. And uh, so we call dev portal, basically it's so anyone can actually sign up there. And initially it was a very slow journey, but now we are more than actually 500 users on our dev portal. So all our tech which we use is I mean, just before the talk was about to start, so we are talking about how these cloud technologies has really helped us to we, as a Blue Sky, so we are actually working remotely. So the technology has a great role to play in it. So why we are working remotely, and especially the cloud technology, where we can actually access the data from anywhere. So actually I come from Chandigarh, but right now I can access my data set. I mean, I come from Chandigarh, but right now I'm based in Mumbai. So I can actually, I'm working while I'm in some other place. So I can like do whatever activities I was doing at another place or my office. I can do it from anywhere. And that's how actually the technology has helped us, and especially the cloud technology. Mm. So, I think about 8 to 10 years ago, when I started my master's or my career, so getting data, the right kind of data, was really challenging. I mean, I remember we used to spend a lot of time just to get the right amount of data and then further do the analysis. So now with the increased computation powers, better computation powers, and better internet services, so we are actually able to ingest any amount of data into our infrastructure, process it, and make it to the user available like within few hours, I would say, which earlier it used to take months just to get cloud free data and filtering all those data sets. And that's how the technology, while the remote sensing and the satellites are improving, the technology has a good role to play in it, like while we are talking about it. So very quickly, I'll walk you through. So we call our the infrastructure which we use is we call it geospatial data refinery. So like uh, our previous decades were dependent on oil, and I think almost every data talk they call data is the new oil. So why not geospatial data? I mean, so that's how we try to relate. I mean, when we talk to the non-science users, I mean, so then we make sure that they understand how we process it, where we get the raw data, and what are the processes involved, so that you get the right information. So the raw input can be in the form of satellite data, climate data, sensor data, then sensor as well as sensors data. So there's a lot of uh, data out there. So we make sure that it's like oil refineries. We refine our data sets, and then there are like n number of pre-processing involved. I think everyone is aware who is working on satellite data sets, right from mosaicing to satellite images, pre-processing, and then there are n number of pre-processings involved. So there's a infrastructure we have built that you get any type of data, and it will be automatically processed depending on the the pre-processing or processing required, and you get the data sets out there, be it floods, droughts, air quality, greenhouse gas emissions. Even I'll tell you more about our data sets. I'm actually very excited as these data sets come out and we get feedback on that. And even we can actually monitor emissions from landfill sites or power plants. So that's the kind of work we are doing, and we will do more. And and then you can use it for your use case, and be it because my specialization is in natural hazards and disaster management. So we all, I mean, so I do a lot of modeling on disaster management, risk assessment of these products. So this is the process in general where I mean, this is, I'm talking about a person who understand geospatial data, that they know what's latitude is, what longitude is. But in general, the kind of people we interact, so they just provide us the address of. So then there's another layer, how you convert that address. So then it becomes the address to converting into to latitude, longitude, and then you do the analysis or what they are interested in. And further, so there are different kind of users also. So we have categorized them into three kind of users, where basically there are developers, so they know how to or integrate or how to access the APIs, how they can access the data. Then there's a set of user, uh, so where they are in the middle of a non-tech and a tech. So basically they are kind of people who do analysis on Excel sheets. So we are also trying to uh, basically make tutorials, work with them, that how they can use this data into their Excel sheets. So how they can use it, actually we are putting a lot of effort into that also. And then there's another user who don't understand, but they understand the maps, they understand the visuals. And then we have another portal, we call it space time, where you can actually interact with the data, uh, and be it and any kind of data. And I mean, initially it took us more than 1 year actually to bring one data set on top of space time, where you can uh, temporarily actually see, like Google Earth, where you can see the previous images. So with space time also you can actually interact, like how my air quality is today and what it was yesterday and a year before or 5 years ago on any single day. So that, so I mean, it's so the idea is not to limit these information or the to one set of users. uh, we want to make it available to the everyone. I mean, anyone can, be it lawyers, be it so we actually interact with any n number of people. So very interestingly, I came across this thing when I was trying to explain it, and one of the users, they gave us feedback, especially the science people like us who work, and especially the scientists. They he told me that you guys like do a lot of research to understand the world and communicate in a way that word don't understand it. So that actually line stayed with me. and that even I mean, while we uh, do the research even within the team also, so we try to make sure that everybody in the team, at least even in the blue sky, understand what we are trying to do, be it from the strategy team, be it from marketing team, finance team. So whoever is involved in developing these data sets. So we test our communications within the team, and then anyways, while interact, we get like a lot of feedback on that as well. Yeah, I mentioned these are some of the data sets which we have, uh, uh, which some of them are out and some of them are soon to be out. I mean, there's a all testing is has been done, so soon they'll be out. So I'll talk about more about air quality data sets, and specifically PM 2.5 concentration, how we like what how the idea came about and what we are doing. And then there's another data set where we are actually monitoring greenhouse gas emissions or the trace gases, and specifically carbon dioxide from biomass burning, wildfires, or stubble burning. So you can actually uh, aggregate at a district level or even a village level as well, like which localities polluting more in terms of these stubble burning in general, but overall these biomass fires. The data set which it I mean, the idea to put this slide was to, so I usually put this when I talk to users. So, and it helps us a lot how they can use it in their decision making. I mean, so it's very easy for us to say that our information is real time, but how they can use it makes a lot of impact on their day to day activities. And and also the users who would be interested in using this information. And same with the predictive data sets also. Like one of our data set is we are actually forecasting the fires, the wildfires, where for the next 1 week, where the fires are going to happen. Now the another question comes is, who is going to use this data set? So, and while we were getting these queries, and we realized that all this came into the disaster management or mitigation organizations who are involved this in this, they are more interested in, and then we put them in one set of category. Then there's another set of users who are interested in near real time or real time information, and then we put them into their use case, like how they can use it. So this is in general, like I just wanted to showcase, even if it is uh, the information is there, and but it makes a lot of impact who is going to use that information. So this is one set of a data set which we developed, and actually this was one of the first data set which we did. So this was one of our first data set, I would say. uh, so while uh, like we were working on a problem and we wanted to monitor the air quality of any city or any locality. So what, even if you Google search, so you won't see any air quality information out there. So that's the kind of information is still lacking there. I mean, air quality, and we talk about air quality, pollution, but even if you just Google search it, it's not there. And then the scientist inside me or my team, like when we started digging into it, like what's the reason behind it, then we came across that approximately, I mean, it's very specifically highlighted there. So India is such a huge country, and we just have only approximately 250 air quality sensors actually, but now it's approximately 300 or more than 300. But the figure is now close to 300. I mean, this is one when we started working on the problem. And imagine the level of I mean, each sensor is covering. So if you just simple mathematics, so one sensor is covering approximately 13,000 kilometers square of India. And and just one sensor cannot tell you the right information. And that's where satellites come into, they play a very significant role here. So then we started researching about, okay, there's a satellite data, so what all information do we need to estimate these air quality using satellite data sets. And then we came across weather parameters. I mean, the satellites providing weather data. Then there's aerosol optical depth. I mean, I mean, I won't go into the detail about it, but that's where the satellites are there. I mean, they provide all these informations. And then we uh, started experimenting with our statistical models or machine learning models. And finally, we were able to produce PM 2.5 concentrations on a daily scale. I mean, every 24 hours, you'll see how much India is polluted. And that's there. I mean, and it's been active since last more than 3 years, and we have a very huge amount of data, almost estimating PM 2.5 every day. And it's not just that, but we also try to validate it with the ground sensors information. I mean, I've previously mentioned all sorts of raw data sets which goes into our modeling infrastructure, and then this is the kind of information you see, how the dark spots or the red ones are the polluted regions, while the bluish ones are the non, or the where the PM 2.5 concentration is lesser. And this you can visualize every day. Right now, this information is limited only to India, but eventually we are targeting to make it at least available for South Asia, and then we'll move it to other regions also. And while this is a science part of it, now the next question is like, who is going to use this information? Who is interested? And interestingly, uh, there are users actually who like health industries. They are health industries one which is there. I mean, our topmost user of this data sets, so they can actually plan. And actually, so before I tell you, so we did a very small I would say a case study. So where we realized that so as soon as the pollution peaks, so the footfall of users or the patients increases in the hospitals. So it was, although it was not very I would say a very scientific, I mean, according to all the samples where we collected the samples, it was not a very scientific study, but it was very general. Like, we just wanted to understand the phenomena, how pollution affects the health wise. Imagine it was just a, I mean, very small data set science wise, but imagine if you can do it a like long term study, and we can actually assess the health impacts of this air pollution. And health care industry is one of the topmost user of our this data set.
So Ishaan, can I ask a question here?
Yes, yes, please.
Yeah, I just intercept. So I see a lot of students in the audience. So I thought some of the things the students would be interested in is, you mentioned it's a small data set, and I believe you said that in relation to the larger data sets that you work with, right? And so can you give some specifics as to how big the data was, and how did you handle these heterogeneous data sets, right? So what kind of, do you have a system that is built at Blue Sky Analytics that helps work with different types of data, modalities? Or do you have any tips as to how students can work with them? So that will be interesting for the audience to also understand.
Okay. So our entire infrastructure is built in top of cloud technology, like similar to Google Earth Engine. But unlike Google Earth Engine, so if I think a lot of students nowadays, they understand what Google Earth Engine and how it works. But in our case, so we have to develop it from scratch, like right from getting the raw data. It's like you are getting the raw data from, let's say, from NASA or ISRO. So you get the satellite images from them. It's stored in one of our database, or the bucket we call it. And from there, so everything we do, it's all in Python. So all the processing you see, it's all in Python. It's just uh, the the cloud platform gives you the capability to handle such huge amount of data sets, be it a country specific or a global data sets. And it's a very huge data set. I mean, sometimes it's approximately 50 GBs almost every day. Now it's not like we are handling it now, the system is helping us to handle this data sets. But we need to know, okay, so like I'll tell you this ECMWF data sets. So I'm not sure, like you get like more than let's say 100 bands in a one stack. So but we are not interested in all the 100 bands. So we just extract the relevant ones, maybe 2, 3, or 4, or maybe 10 of out of that. And then we use that information, combine it with maybe modest data set, and that's how we do the modeling part out of it. But
You communicate the air quality index or equivalent value every day, is it? Or did you put it out to the users to see that? Is that?
not exactly air quality index, because air quality index, if we see globally, so there are different definitions of air quality as well.
Exactly. Yeah.
So WHO, and I mean globally it has a different definition, and in India we have a different definition. So right now we are not focusing on delivering AQI right now. So
Mhm.
it's limited only to PM 2.5 concentration.
Oh,
But I mean, the models are there. It's just we are not putting it out for PM10 and other pollutants.
yeah.
So eventually, I mean, it's a process of time also. I mean, we want to test it internally and then put it out to the world.
You mentioned something about expanding this work to other countries, right? So if you have to expand it to, say, the entire Indian subcontinent, uh, what are the kind of challenges you would face?
Uh, the one challenge which I see is the ground data. I mean, how we are going to validate it with, because being an Indian company, so it was easy for us to access the ground data. I mean, collaborating with CPCB or some other organizations who actually they are the ones who are handling the data set. But so there's a lot of challenge even with other data sets also. I mean, if we are developing some of the data sets globally also, so the real challenge is how you are going to validate it on ground with ground information. So that's the challenge is always there. But we are always looking for some proxies as well. I mean, we are trying to at least trying to verify it with high resolution satellite data sets sometimes. So it also depends on the use case, how you are going to validate. But in general, it's always the real struggle is the ground data.
So there's one question. I think we can take this question, and then after that you can move
Sure,
on
sure,
to
sure.
your next example. So question is from Ansi on how different is air quality data of CPCB and that of Blue Sky Analytics.
So CPCB's data set is monitored using ground sensors. So everything you see on CPCB's website, so it's all coming from ground data, all the ground sensors, while Blue Sky's data is all derived using satellite data. And it's all, but we do validate our results with CPCB. So because that's the actual real, I would say, the information as possible because on ground. But with satellite data, there's always a challenge that there's a n number of layers how you're going to validate it. So the actual picture is coming from the ground sensors only, but they also have their own limitations. And actually, in my next slide, I'll show you. This is something, and also if you look at CPCB's website, so they provide their data sets either in the form of PDFs. Then that's another challenge. How you are going to make it automated, or how you want to make it available, and you want to make the information. Users may want to use it in real time. So I'll tell you, there's one of the biggest customer, one of our biggest customer. So they are one of the major wearables which we use, like the fitness bands. So they actually use this data set, which I'm not allowed to put out the name of that company, but they are one of the users who consume our data sets, and that's the kind of user we see. Then again, it's a very simple. If you look at 365 rasters, if I'm talking about students, so we just calculated the number of clean air days India has, and you can see the north region, and they are the ones which are like the most polluted throughout the year. Topography has another role to play in that region, but in general, we looked at just uh, uh, I mean we had 365 days of rasters every day, and then at the end of the year we just wanted to see like how it's working. And then this India Energy Outlook, they use this analytics map of us, and they used it for their further analysis. I think you also asked me about the limitations. So uh, I always try to make sure that not just me in general in Blue Sky also. So the kind of information you put, so also make sure that there's always there's no data set, or there's no data which is perfect or 100% accurate. So we have to put out like, if even if the data is 80% or 90% accurate, and what are the reasons of 10%, like why it's not 10%, and there's always going to be limitations. So if you see, even if CPCB has ground sensors, they are up now 300, and especially it's very difficult to validate our results in the hilly states, and there are different challenges in monitoring air pollution in hill states. And and uh, I think Delhi is not very specifically highlighted, and Delhi has a very small uh, I would say area as compared to other states, because we do consider Delhi as a state sometimes. uh, so Delhi has like more than if I'm not wrong, like more than 15 sensors. And then there are states where you have just one sensor, or even there are states where there are no sensors at all. So you can imagine the level of information available. And even then we further looked at where these sensors are installed for CPCP, and most of them are based in urban localities, and you don't get the rural pollutants or rural picture, like what's happening in the rural regions with this. I mean, that's the uh, I mean, capability of satellite data, where there is no there are human limitations to capture the information. It helps you to capture the right kind of information there. And sometimes it may not be accurate, but it gives you a proxy, so that you can compare it with other regions if you are having the same source of data set. So if I think we still have time, and I wanted to talk about this uh, global greenhouse gas emission data sets, and specifically CO2. Uh, so these fires, they have a huge role to play in it. And uh, and when I say fires, they are all coming from this vegetation. These are forest fires, wildfires. Then there's the stubble burning also, which plays an important role, not just in India. I mean, I know, I mean, there are states, they are the hotspots of stubble burning, but if you look at the overall picture, how they are contributing globally, and that we can actually quantify, and you can visualize it on space time as well. I mean, I would recommend to everyone just to go there, play around with the data. And we are also working on internally within the team that let's put out these data set to the students also, or to the academic users of this data set, so that they can also understand blue skies data set. These are some of the snapshots actually. If you see how you can actually compare which country is contributing as compared to the other one. And if you look at the Indian region, you can compare it at state wise and where the pollution hotspots are. And on if you and further, if you break it down, you can even compare it with village and even farms also. So another user of this dataset is there's a coalition called Climate Trace. So it's a coalition of non-profits, startups like us, and then there are a few more organizations who are actually monitoring the sources of carbon. So, like as Blue Sky, we are monitoring farm fires or agriculture cropland fires. Uh, there are other organizations who are actually monitoring these emissions from shipping sector, real estate, uh, and the major 8 sectors, I would say. And this is how our data is being contributed to that platform. And it's a Climate Race is actually supported by ex-US Vice President Mr. Al Gore, and we were the first founding members of this coalition. So anyone can actually go there. The methodology document is there, so that anyone can uh, access the data as well as the science or the documentation part. Then again, I mean, if I'm not sure the kind of users, I was not aware. So then again, satellite, if you are capturing the fires or the emissions, satellites, uh, they has their own limitations. uh, so one of the satellite we use is I think VRS, and it captures these fires every 24 hours. So if you understand the fires, so they are not so what happens within those 24 hours, it won't be able to capture it, and that information won't be out there, and what are their contribution to the emissions, it won't be captured. And now we are also trying to integrate other sources of satellite data sets where you can actually monitor 24 hours of where we will be using these, they call it geostationary satellites. And then we'll try to integrate both the satellite data sets, and then improve our accuracies or results and how it works. And then uh, if, especially these greenhouse gas emissions, they if you look at it, so usually there's no way to validate it. So we just try to validate it with whatever the global inventories are out there. So we just try to compare it with them, like, okay, this is what they are doing, and at least how accurate we are. So we just try to validate our findings with them as well. I mean, again, it's a part of improving our research only, how we are going to improve the results. And always ground truth has a major role to play. So this is actually another set of uh, data set. I can talk about all the data sets one by one, but I just limited only to two data sets right now. But I mean, these data sets are soon they'll be out, or some of them are already. There are users using the data sets where you can actually monitor the water quality. You can quantify the water surface. The water bodies, all the lakes. Then there are I'm the part which I'm excited about is power plant emissions. So you can actually monitor the emissions from every individual power plants. Uh, so the interesting part with power plants is if you look, this is not just the problem is limited to India. So if you look at globally, so there are countries like US and Europe, they are monitoring their every source of emission almost 24 hours by 7. Almost every hour they have the information. And then there are few countries which don't have the information at all. So now if you so there's one of our partner members, partners, they did a study where actually if you look at these COP 21 and the COP, recently we had this COP 27. So in COP 21 our global leaders were actually, they signed an agreement to cut down their emissions. But how are we going to cut down our emissions is something we need to have the data, right data, like which sector is polluting more. Then only we can have the right kind of policies, or uh, take action on the sources of emissions. And then just these agreements were signed almost 6 or 7 years later, just before this recent COP 27, which happened in November, I guess. And just before this, we one of our members, they did the study and realized that only 100 countries, they have not updated their these inventories. And imagine how we are going to take actions against these sources of emissions. And now there are countries which are they have information almost for every hour, and then there are information where there's no information at all. How you're going to compare it? And then again, satellite data helps. So we did a study. We actually uh, uh, I mean wherever possible, we could get the ground data from all these power plants, and estimated these emissions from using satellite data, and compared all the regions where there was no data and then there was data. At least, it could make some sense to further take actions, and we could know like these are the regions where potentially we need to do more work, or where we need more ground truth data. Or if there's no ground truth data, at least we can compare it with some other sources. That's a the whole idea about I behind it. You can actually uh, n- monitor these things at global scale. uh, you know so while I attend these conferences and also, so it won't take much. They say like, okay, so this some ppm levels, it was just 415. Next year it's going to be 416, and after that it's going to be 417. So it's just a 1 unit change. But if you further look at country scale, and how, then you realize the actual things happening. And further, if you look at how the state governments are acting, or how the local governments are acting, then the real source of information or the polluter comes in. Okay, so these are the actual sources which are polluting more.
So, Ishan, that's an interesting point you make. So, from just completing that loop, right? So,
Mhm,
if you look at it from the multi-scale point of view, you said
mhm,
the government interventions help if it starts from the local level and all that. But so let's talk about a little bit about how you handle it, the data, right? So do you have different kinds of, say, machine learning or deep learning models when you change the scale, in your experience? For some of these examples, maybe you can throw some light on that. Say, if you were to work with the data, say at the state level, and then you need to collate the data along with like the neighboring states and then consider it at the country level. So do you have to use different kinds of models, or do you already use different kinds of models? And
So when we start any data set or any problem, so we just first test it with one set of, let's say in the case of these power plants, so we treat it like individual power plants as one. And I think there's a thing called data labeling in this. So then we, I mean, there's a geography, another has a role to play in it. So then we do it for one district and one state. And if uh, then there's an interesting thing called we have this data sets provided by WRI actually. So they even have the type of power plants, the kind of fuel used in these power plants. So there are different tries, a set of combinations we try, like whether this variable has a role to play when we estimate these emissions. So now once we come to a certain point and experiment everything, okay, this model is giving up some level of results, then we expand it to other geographies also, and then I mean within India, then outside India, and then wherever possible. I mean there it all depends, the n number of variables you get, your model accuracies will improve. But usually we start with one plant or two plants only, or the specific region, and then it comes, it's it's just a comparison thing, all the stats, like you aggregate it for a district, then you compare it with another district, it's just an aggregation part.
okay, so for the reason why I asked about the scale is also because I wanted to check. See, for some applications, like not exactly related to power plant, but you mentioned that you work with hazard mapping and all that. So if you look at hazard susceptibility mapping, you will, I mean, at least in the literature, you would see that most of the studies are done very localized. Like they would take some part of the Indo-Gangetic Plain valley and would study just that. And they would apply some sort of machine learning algorithm or model or deep learning models nowadays, right? So, and then they would do analysis of susceptibility of floods or landslides or whatever that particular region. And somebody else would study for like, maybe adjoining, but or non-overlapping regions. So what I'm trying to ask here is also, when you improve on, when you increase the scale, can you reuse some of these models which are probably not homogeneously developed, right? The variables used are different, models used are different. So do you come across cases where when you have to aggregate that you mentioned at scale, do you use whatever is available or what worked at local scale, the results, and then aggregate? Or do you run a new model altogether?
uh, so in case of floods, actually we came across this problem. So we selected one of the region for this flood modeling and flood risk assessment of flood susceptibility map. uh, so the results you can get it, but then again the models which work in one locality won't work in the other ones. So so either we make it that problem multi-model, because within India also then we have to run, let's say for 8 different geographies, you have to run 8 models. But then we know like this is the result of model 1, model 2, model, like different geographies, then we aggregate it, and then how the information is like shown to the user.
So right
And
now it has to, I mean, by virtue of the science involved, you do late fusion, right? That is one way
No,
to look at it.
not right now, but like for air quality, so we did experimented with different things, because uh, so our one model worked for the entire country, because the kind of data we were getting is it was representing the entire India.
Right.
But with but there are certain challenges. I think I've mentioned that the hill states, but they still show some inaccuracies there. Then we have to treat those hill states as a separate region and retrain our model, and then combine the results, and then you can show it to the user. But this is always there. Even if you look at building footprints, if you are trying to monitor it using deep learning, so I mean, it's all about the kind of exposure you give it to the machine or the data sets.
Exactly.
Yeah, so it always this challenge is there.
So on a related note, I mean, interestingly, you mentioned this thing about hilly areas and limited data. And all. So do you see a lot of scope of few shot learning in these kind of applications, or have you already experimented with some of these?
Uh, we are experimenting. I mean, always so it all about priorities, how the team is planning to work on these things. Then again, I think I've not mentioned, you've highlighted that, especially our models, even with the CPCB also. I mean, we were not realize this later, that our models did not perform well, especially during peak pollution hours, and especially during Diwali.
Oh, okay.
So
That's
so
interesting.
uh, they just go like give
Not
because
yeah.
the model is not used to these high value of pollution levels, so they
Yeah.
are not used to it. So
Mm.
our prediction goes like haywire. And same with the, so I we discussed this thing with the some experts from IIT Delhi, and even with CPCB guys also. So we discussed why it's like this is happening, because I don't come from air pollution background. So my background is purely remote sensing. I understand satellite data, and and top of that, my graduation is in electronics and communications. I understand how the sensors work, but I don't understand like why it's happening, like what's the reason behind it.
Causality, yes.
Yeah. So then they say, no, the same thing happens with them also. I mean, even whatever they are predicting, so they do these predictions or as forecast for pollution separately. So they treat these events separately. So that's how we came across. I mean, then we realized, okay, that we need to do
Actually, there's a
retraining.
question in the chat by S. Hegde. I think it's good time to ask that. So
Mhm.
he or she asks, CPCB accepts data provided by Blue Sky. Do they accept the data? I'm guessing probably they. If she mentioned if it is your inferences are being used by CPCB or not.
No, actually, we uses their data sets for our validation.
Okay, all right.
We are not, they are not using our data sets, but
Okay,
there are
it's
other
not the other way
users.
around.
Yeah,
Okay,
yeah,
all
yeah.
right. Okay, that's interesting. Yeah, can please carry on with your talk.
No, it's okay. I mean, if you have, I mean, this is getting interesting. So even
Okay.
there are things being discussed which even I also not realized. Like, I mean, and just giving some of the examples of our data sets. This is something forest, and again, I mean, uh, it's again come to what we discussed previously. So these are the different case studies I just wanted to highlight, like how the user wanted to understand, like some of the users, they want to understand the global phenomena, what's happening like globally, then how different state of I mean interventions or state level organizations, they want to work on it. And nowadays there's a trend of concept of these carbon markets. So they are also actively consuming this satellite data, and especially uh, how these forests are being monitored, and how much carbon potential they have, and how much carbon they are releasing if you cut them out. And there's a concept of carbon sequestration, like if they adopt certain area of land and they grow some plant or trees there, now they want to monitor, okay, like this much level of they are polluting through their let's say industry, and now they want to counterbalance those emissions by growing trees. So that's the kind of work there's, I mean, I'm not fully like I'm not the right person to talk about more into detail about it, but this is the kind of information, or the kind of uh, work we get a lot of queries about whether we can do, and we can do using satellite data. I'm fully aware, like we can actually monitor reforestation, deforestation, the carbon potential it, but then how you can combine it with the finance industry, like how they can use it, then we have a separate team who actually work on using these kind of data sets. And same with the lakes also. So these are some of the highlights I just wanted to show. So while actually we were coming or developing this problem, so we came across that there's no data set actually out there which you can actually get the, like how many lakes are there in India and how many lakes are, it's just the Google, you can do it like manually pinpoint, but there's no database actually which can give you all the lakes. I mean, there are databases out there where, like Ramsar data set talks about wetland and all, but they're all either too technical or too scientific. But for general audience, I just wanted to know that how many lakes are there in my town, like how polluted are they, and how I am going to use this information. So while I started working with Blue Sky, now I do like two things every day, like monitor, like check pollution every day on my like space time or web app, and I try to see the pollution, lake pollution level, like almost every month or every week, I would say. It also gives, I test my estimates also, like whether I'm like we are testing it, doing it right or no.
So, Ishan, there's a related question
Mm-hmm,
by Pratisha.
mm-hmm.
Pratiksha. So, she's asking, what are the water quality parameters provided by Blue Sky? Is this a global data set?
uh Not yet global, but so it's, we have experimented, I mean, the, it's not out there because we are still trying to validate our results. So it's limited to India, US and Europe. So three countries. I mean, Europe, like all the European countries, and USA. And if you talk about water pollution indicators, so it's I'm not sure. Like I don't have the list of parameters, right? All the parameters right now, but I know about chlorophyll content, turbidity, and there are a few more actually, like four or five, not all the pollutants right now.
And Gurudata asks a question, which seasons are the lake water pollution more according to your monthly analysis?
Uh, I don't have the like figures with me right now, because it also depends on the lake and the geography, like where it is. But usually what the turbidity especially changes during monsoons, like if you look at it. And we were actually monitoring these Pakistan floods actually, using these satellite data sets. So what we observed is, while we were monitoring the pollution, I mean different indicators, and we were also quantifying the lakes, like how they are doing in terms of the water level extent, not the depth part, but the in general the extent part. So while all the like major lakes globally, they were shrinking, so the Pakistan lake, it actually got flooded because of the rains. And we could literally we could uh, that lake is very close to river Indus there, and we could differentiate it just using their I mean pollution levels, I mean the water level indicators we use, just for using the turbidity. So that lake is a freshwater lake, and the Indus water was, because of floods, so all the I mean the lake, that water was all turbid, I mean it has like all solid mud mixed with that, so we could easily differentiate those.
Okay. So, Ishaan, would you consider these events as anomaly events? Going by the thought, Dibakar has also put in the chat on when you talked about the Diwali pollution that it is probably an anomaly. Um, uh, and so, how do you handle such anomalies? Do you see a lot of them in the data sets that you encounter? Have you seen more anomalies nowadays given the climate change context? So,
Not exactly, because as compared to I would say Diwali,
okay.
but no, but sometimes some of the events are there, even models also fail, but these events are not like frequent right now. But we do see, I mean, I'm not sure, like I don't have the figures with me right now, but we do see uh, like pollution like for long number of days in certain regions where I think it should not be there.
Okay. So you would consider that as an
Yeah.
anomaly then. So what about flash floods? Would you consider those as anomalies then?
uh right now, I mean, I'm not the, I mean, it's an anomaly, but
You're
we are not
studying.
actually trying to work on flash floods as such,
Okay. Okay.
because we really need to work on the definitions also, like
Okay. Yeah.
how the satellite is going to capture these. So our like while we are working on any problem, so we really put a lot of effort on the definitions also, like what exactly the
Makes sense.
problem is.
Yeah. Yeah. Yeah.
But we just whenever we start experiment, we just try to start from the simplest solution, like what can you do, like just from it start with preparing the database. Okay, let's collect like whatever information is out there, and then slowly, like with every iteration, we just try to keep it improving. And with us engineers, it's a problem that we always want to work on the hardest problem, always.
Mm.
But and then but we also need to make sure that whatever we are doing, it the problem, it should solve the purpose also
Right.
for the users.
Right. And please carry on with your
Yeah,
talk. Krishna. Yeah. Thank you.
I think I've mentioned about this slide previously also, like we categorize our uh, users in three different categories, like our consumers. One is we just provide them the analytics or the Excel ready analytics, and then space time, and there's API gateways who can use the data sets. So this is a team. Blue Sky Analytics was founded by Abhilasha and Kshitij, and started with 3 people, and now we are approximately 30. And these are some of the advisors, and actually we are looking for more advisors, especially from the academic world. And like the kind of research we have done, I think academic point of view, it's very interesting. And we are all just trying to put white papers out there, and soon we'll be publishing some of our I mean, putting out our research papers as well. And we'll be collaborating with professors and from IITs and from other organizations. And we are always looking for these advisors, seek their feedback, like the kind of work we do. It's not just the one way, I mean, thing we want to do. So it's whatever the decisions, I mean, whatever the data sets we should bring out, it should be supported by science. And these were some of the uh, highlights or the achievements in the last 4 years we have achieved. And actually, Blue Sky Analytics was the one of the first Indian startup which was supported by MIT Solve. And uh, there was another event. Uh, I think it's not highlighted there. It's a ESA BIC, which is actually supported by government of Netherlands, and one of our entities registered there. So they are actually supporting these kind of space initiatives, space startups. Yeah, that's it. I think we have enough time for question and answers. So if you have like more, you want to learn more about anything, you can always reach out to me. And if you have any more specific questions, we can use this time further.
Yeah. Yeah. We already have a hand raise. Yeah, Pratiksha, it's anyways a small crowd here. You can unmute and ask your question.
Yeah. Hi, Ishaan. Thank you for that nice overview of Blue Sky Analytics and the products. So, I had a question regarding the product that is for fire event predictions.
Mhm.
So, I wanted to know if there is some sort of estimate of confidence associated with these predictions, and also if these predictions have been validated, and if so, what kind of accuracy will you get?
So yes, so we do weekly forecast for these fire events, but we experimented it with different intervals also. But then we like came across like the week thing was working perfectly, and then yes, there's always a accuracy indicator there. And right now our models, if I'm not wrong, they are achieving approximately around 70 to 75% of accuracy, like with these. And while when it comes to validating, so it's always like when the event is actually happening, or the you get the actual observations, and we validate our predictions with the actual events, and that's the only source right now we have to validate.
Is there any confidence estimate for these predictions? Because as I understand, a prediction of a fire event would involve like on-ground mobilization of resources. So, like the users of the data would like some sort of
Yeah, I mean, yeah,
confidence
it's
associated.
always there. The accuracy indicator is always there, like the or the what you are mentioning. It's always there, like the accuracy indicator, right? So it uh, so like for weather events also you get these, like you are going to get this rain. This model says like 80% chances of getting rain. So similarly, it's just a matter of how we are communicating this information. We are working on that, but in general, from the data part, so our models are giving like quite good enough results. And but yeah, some of the things where we fail it, where anthropogenic factors are involved, so there we are not able to actually get the predictions, like the stubble burning. So you do get the estimates, like at least for a week, or like more than a week, where we know like these are going to be the hotspot of fires, and they are influenced by human factors, anthropogenic factors, that the model is right now not able to capture well. But otherwise, in general, wherever there are natural factors involved, it's giving good results there.
What is the resolution at which this is doing?
So right now we are estimating it at, I think, 15 kilometer of grid. So
Okay.
we just split the entire world into 15 kilometers of grid, and then we estimate it.
Thank you.
Thanks, Pratiksha. And any other questions for Ishaan? Ishaan, you have been very patient answering questions.
No, but this is part of my work actually, and this is all about this session.
Right.
But, and this actually helps a lot to improve our data sets also. I mean, sometimes we don't realize while we are working on a problem, but when you get the right questions,
People, yeah, with the community, you get to know more.
yeah.
I think, yeah, it's been and yeah, a little more than an hour. So I think we can wind up. Thank you so much, Ishaan. A big round of applause to Ishaan for his talk. Okay, Dibakar is asking link to your data set. So if you have any links you can provide on chat.
Yeah, let me just because some of the data sets are already, I mean, out there, so you can always check it on our website. And I would recommend going to blue that space time. Let me just share the link as well. So some of the data sets are already there. So yeah, so the to the previous question I mentioned 15 kilometers, it's 25 kilometers. So I just realized that grid.
I actually have another question.
Mm-hmm.
So, you mentioned that you also do landfill detection, right?
Yes, yes,
So
yes.
this is again, is this a global data set or specific to certain regions?
We started with the major landfill sites in India, but then now while we were discussing, we realized again it's a global problem. So so we also consider while we want to make it global, but then with every step there are computation challenges involved, like how we are going to store the data set. So you won't see this data set on a website about landfill emissions and in general landfills, but this data set is going to be we'll start with India and then slowly move out to other regions.
Right. So my question actually is, have like what kind of heterogeneities do you notice like within whatever region you take? As in, what are the challenges in terms of heterogeneity?
So it's a kind of, actually waste also has an important role to play in these landfill emissions. And I mean, right now we don't have the right data itself to capture these, but in general, what we realize, I think the methane emissions were quite significant in Indian region than the other parts. So we don't know the reasons right now behind like what's the real cause of these, and soon we'll figure out um, what's happening like globally or in the other regions. But the waste has an important role to play, like the kind of waste we put into our landfills.
Okay, thank you.
Thank you, Ishaan, and it's congratulations to Blue Sky Analytics for all the achievements you had mentioned. It's I wish you many more going forward. For a young company, it's quite an accomplishment. So thank you, Ishaan, and for graciously agreeing to give this talk and patiently answering all the questions and giving a wonderful talk. We are very grateful to you. So on behalf of IEEE-GRSS Bangalore section, we'd like to thank you.
Thanks so much.
Yeah. So with that, we'll sort of close the session. But before we go, I'd like to mention next week at 5 p.m. On Friday, we will have our next Bhoo-Mandal talk. This is by Mr. Amrit Kiran from Indian Institute of Human Settlements, and he is going to talk about building the India data queue and his experiences working on ODC framework. So with that, we'd like to conclude today's session. Thank you all for coming and staying around for this long. It's been great. We're happy to have you all here. Thank you.